What's going on, Algebros? It's Mr. C here, and in this video I'm going to help us solve the rational equation 3 over x plus 5 over x plus 4 equals 1. Recall that this equation was derived based on an application problem which wants us to calculate two different speeds, a jogging speed and a biking speed. 3 over x would represent the portion of 1 hour that it takes this person to jog a distance of 3 miles at a rate of x miles per hour, and 5 over x plus 4 represents the portion of 1 hour it would take the person riding the bike a distance of 5 miles and at a rate of x plus 4 miles per hour. So as you can see here, we have an LCM already provided for us. It's x times quantity x plus 4. And the first thing we're going to do to carry on with the rest of this problem is distribute that to every fraction involved in this equation. All right, by that I mean we'll take x times x plus 4. We'll put that in front of the fraction 3 over x. We'll also put x quantity x plus 4 in front of the fraction 5 over x plus 4. And we'll also put x quantity x plus 4 in front of 1. And there's the 3 over x. All right, so what we'll do is figure out how things simplify. Remember, the point of the LCM here is to clear all the denominators. If we look at our first fraction on the left, we see that x is going to cancel out with the x from the LCM. What's going to be left over is x plus 4 times 3. In the second fraction on the left, quantity x plus 4 is going to cancel out, and what's going to be left over is x times 5. On the right hand side, nothing cancels out. There's no denominator underneath 1. So we'll just have to work with that as it is. Now, to clean things up on the left, let's write the first fraction simplification as 3 quantity x plus 4. Second fraction simplification will give us 5x. On the right hand side, let's write that as x quantity x plus 4. Now we'll clear parentheses by distributing. So we get 3x plus 12 plus 5x on the left. On the right, upon distributing x to each of those, we get x squared plus 4x. And as you can see, we wound up with a quadratic equation. What I recommend doing from here is combining like terms and setting one side equal to 0. If you look on the left-hand side, we can combine 3x and 5x to get 8x plus 12. No like terms on the right-hand side to combine, so I'll just jot it down again. Now we're going to set things equal to 0 by subtracting 8x and subtracting 12 from each side. When you do it on the right-hand side, subtract 8x from 4x, and then when you subtract 12, imagine there's a 0 up there that you would subtract 12 from. And on the left, we get 0. And on the right, we have x squared minus 4x minus 12. So what we've just done was put the quadratic equation in standard form, set equal to 0. What you want to consider doing next is perhaps factoring the right-hand side. You want to think about factors of negative 12 that add up to negative 4, and there are definitely two numbers that fit the bill. That would be negative 6 and positive 2. So one factor, it's x minus 6. The other factor, it's x plus 2. Next part is to set each factor equal to 0 by virtue of the zero product property. We get x minus 6 equals 0, or x plus 2 equals 0. Go ahead and add 6 to each side in the first equation. We get x equals 6. Subtract 2 from each side in the second equation. We get x equals negative 2. So we do get two answers, as we typically see with any quadratic equation. But keep in mind the context of this problem. We're trying to figure out two different speeds, a jogging speed and a biking speed. Recall that x represents the jogging speed. So with that said, negative 2 miles per hour doesn't seem to line up with ordinary logic. Therefore, we would have to stick with only x equals 6 as one of our answers here. So with that said, 6 represents the jogging speed. So we'll say jogging is 6 miles per hour. Now, how do we find out the biking speed? Well, it does say that Mark, who's the guy doing the workouts here, he rides his bike for 5 miles at a speed that's 4 miles per hour faster than he jogs. So it's based on the jogging speed. In fact, the biking speed is 4 miles per hour more than the jogging speed. So we could write 6 plus 4, which gives us 10, and that would be 10 miles per hour. And that concludes the solution to this example. As always, let me know if you have any questions. Otherwise, thanks for watching, and I'll see you in the next one.